it's like a little bit introduction about the EduConnect Rwanda. As my director or my CEO said, no need to repeat it again. And this is our vision. This is our mission and the vision. No need to look it into again. So this is my course of today. We started by introduction to statistics course. The table of content, as you see, what is statistics, why statistics is important, key terms in statistics, types of data. You say, okay. Anyone who has a question before we proceed? Okay, if there is no question, we can proceed. And we look at the types of data and even basic statistical techniques, measure of central tendency, measure of variability, visualization data, and we look at the conclusion and even the question, as I said before. So our first presentation is about what is statistics. Simply, the definition of statistics is like a science of collecting, analyzing, presenting, interpreting data to make decisions. When you look at the line here, you see that we have what we call statistics decision making. So which means for us, we need statistics so that we can analyze, correct, present, interpret the data for the purpose of taking decision, maybe for the specific problem that the society has. And when it comes to the purpose of statistics, all of them is correct, or there is some who is the wrong. It is where we use statistics to improve quality control. After seeing that there is some matrix which is not good, they can improve their numbers after looking the different factors that can cause that matrix to be unfitted way. Based on the research or based on the statistics they apply from them. Maybe they can do the research in terms of assessing the effectiveness of the materials that they use, and after getting the information through the statistical method, they decide to increase something which is related to improve the quality in their industry. This is where why statistics is important in any field. And anyone, they can give you an example about why is the statistics is important. As here is just like an overview. There is many important of statistics in general. So if there is anyone who has a question, they can ask before we proceed. Okay. Here there is a key term in statistics. So in statistics, we have what we call population, we have what we call a sample and variable and even data. So when we say a population, let me say this. By definition here, the population is like entire group being studied. But simply, when we say population in statistics, it's everything that can provide information. Everywhere that we can get information. This is what we call a population. And simply to define a population, everywhere, everything that can provide to us any kind of information. Maybe a tree, a house, a person, something like that. But especially it's everything that we can gain information from them. And the sample is subset of population. When we say the subset of population, maybe by giving you an example, let's say that we have a population of a person who has maybe a victim of, maybe who has we have a population of person affected by malaria in Rwanda, for example, or people affected by malaria at that time in Rwanda. All those people located in Rwanda, it's what we call population. So when it comes to sample, it should be sample when we see that to cover all people located in our country who has affected with malaria, we don't have enough time, or we don't have enough money to assess them, and then we do what we call, we select among those peoples located in Rwanda who affected with malaria. They select one of them among of them to represent others, maybe because of their materials to assess them. So those people who are already selected to represent others, it's what we call a sample. And then the variable, it's like characteristic of interest, something that we are interested to look for that person affected by malaria. Maybe I want to see the income level of people who are affected by malaria. So those things that we are interested to look at the population, or to look at the sample we take from the population, so that we can generate, so that we can generalize our population. It's what we call a variable. So simply the variable, it's like what we are interested to look for that population, what we are interested to look for that people, they selected from that population if they use sample, which means in research or in statistics, to use population as entire group being stated means to use all population, all element within population, it's allowed. But also when you don't have enough resources to conduct the study for whole population, you can take among of them, you can take among of them to represent the others. This is what we call the sample. And the variables, it's what we are interested to look for that population we are already studied on. And when it comes to data, it's information collected from observation. As I said before, data should be a piece of information, and also observation should be an response. Let's say observation as a response. So when we ask the question, maybe we are interested to see the income level of people affected by malaria, and we asked the question about the income, how much did you earn during over the month, maybe from one participant to the 1,000 participant, each they give you a specific amount that they earn during the month. So all those responses that you get, when you combine together, it's what we call an observation. So I think if there is no one who has a question about that, we can proceed.
Can you repeat again about sample?
Okay, thank you. When we look at the sample, Rio participated in this session, it's about 57. Those total numbers of participants, it's what we call population, and should be the sample. If we take a few people from that participant who attended online to represent the others, maybe for the purpose of assessing their knowledge. For example, at the end of this session, I will give you like a question so that I can assess whether you understand the session. So among of them, I choose some people to represent you. This is what we call sample. I'm not sure. I didn't. Maybe I may not have a full resources to conduct a study for all people, and then among of them, I can choose some of them, some of you to represent others. This is what we call sample. I don't know if you understand the
Yeah,
question.
understandable. Thank you.
So thank you. We can proceed. Okay. And in statistics, we have two types of data. You guys, I request you, I would like to make sure that you understand the difference between data type, because to know the data type is like a foundation of analysis and even decision making. So if you didn't know how to define the data type, it means that you didn't know any type of analysis that you can do, which means each data type has their respective analysis or respective techniques. So we have seen that in statistics, the data is like a foundation for analysis and decision making. So to understand the different types of data help us in choosing the right statistical method and techniques for analysis. So we have two types of data. One called qualitative data, and the last one is called numerical data. We can say qualitative data or categorical data, or we can say quantitative data or numerical data. So when we say qualitative data, it's like non-numerical data. It's data that can be presented in terms of name, in terms of things. Like they express feelings, strength, direction. Just they give you the status in terms of speaking. We get that data in terms of asking question. Yeah. It's like non-numerical data. By giving you an example, it's like here, color. I'm interested to see the colors of Rwandans. Maybe I asked, what is your color? Maybe they say I'm white, I'm black, something like that. Or we are interested to see to know the colors of this PowerPoint presentation. Someone can say, I see the red, other they can say, I see the blue, I see the white. Those kind of information that need to be participated in terms of interview questions, in terms of asking question and ask that question. It's what we call qualitative data or categorical data. So within that qualitative data, it's where we have what we call nominal data and ordinal data. So I don't have it in this PowerPoint, but make sure that you understand the so within qualitative data, it's where we have nominal data and categorical data. Sorry. We have nominal data and ordinal data. Sorry. Within qualitative data is where we have nominal data and ordinal data. All those are non-numerical data. All those are qualitative data. They express their feelings, direction, strength through the interview question. They asked the question and they received answers just in terms of numbers. Yeah, sorry, in terms of text, in terms of conversation, something like that. When it comes to ordinal data, it's like categorical information where the answers should be like in terms of order. They show us like a level of something, rank of something. For example, on ordinal data, the most of the variables that we have, at the end of the session, I can ask you the rate of or when maybe the rate of understanding, rate of satisfaction during this course. Uh, you can ask, maybe you can choose among like very good, not good, moderate, excellent, something like that. All those they show us their attitude in terms of rank, in terms of level. All those variables that have the nature of that should be ordinal data. And nominal data, it's what we call categorical variables that show us maybe the location of somewhere, the name of something. It's just like a name of something. An example, province in Rwanda. So we have Eastern Province, Western Province, something Kigali City, things like that. It's like presented in terms of name. No need to change anything. If it is Karongi, it means it's Karongi. No need to say that high Karongi. So when it comes to order, it means can be high, low, moderate, or few. But when it comes to nominal, if it is Karongi, you can say it's Karongi. Yeah. And when it comes to quantitative data, it's like a numerical data. Those are the data we get as numbers. So within that types of data, or within numerical data or quantitative data, there is the variables like age, salary, test score, something related to that. So within that type of data as numeric, we have what we call discrete numerical data and continuous numerical data. So within discrete numerical data, those are the numbers that we get through count. Like an example, number of children. We To know the number of children, we can count. Number of people, number of chairs. Those are data we get through count. For those who knows a little bit about mathematics, we can say that the discrete data, it's like those information which should be represented in mathematics as a set of integers. So the set of integers should be it's the numbers which is not be in decimal numbers, which means a discrete data, it's non-decimal numbers. Okay. And when it comes to continuous data, these are information that we get as numeric, but we get it through the measurement. Maybe we can use those measures of scale, like length, things like that, weight, height, things like that. We get data through the measurement. This is what we call continuous numerical data. And question about here? Okay. Okay, I think we can proceed. And we have basic statistics techniques, or most of the time we can say that there is a branch of statistics. Instead of saying basic statistical techniques. So we have descriptive statistics and inferential statistics as two categories or two branches of statistics in general, or basic statistical techniques. So when we say descriptive statistics, it helps us to summarize and describe the data. So maybe by giving you an example where we can apply descriptive statistics, I can correct information from the field, and then before I'm interested to see like the status of that information I corrected from the field. So I use descriptive statistics to present the status of my study before proceeding either to assess the relationship, to see the main reason behind. Just descriptive statistics is to help us to describe what happened. After getting information from the field, I want to know the status of that formation. What happened, it comes from the field. This is where we apply descriptive statistics. And due to the data type, as we have said before, we see that we have two types of data type. Maybe we have numerical data type and categorical data type. So in numerical data type is where we calculate those types of those things like a mean, median, mode, and we are going to see more about that. We have seen that mode, median, mean. It's like for numerical data, we don't calculate the mean of categorical variables. Just to describe what happened by using descriptive statistics for categorical data, so we use a frequency to see the repetition, to see the percentage. For example, when I'm interested to see the status among the gender, I may do the percentage, I may do the frequent, I count the number of female and I count the number of male. Or I can provide the status or description in terms of percentage. Maybe I can say that 70% of participants are male, for example, and 30% of the participants are female. Those are the terms that related to descriptive statistics. And descriptive statistics should be represented as frequency table or frequency percentage on categorical variables. And for numerical variables, we use mean, median, mode, and others. We are going to see it very. And when it comes to inferential statistics, it's all about taking decision. It's involved the prediction or inference based on the data we have. So here, it's where we have like what we call testable proportion. We have the scenario and we need to make decision based on the findings already we do, which means we didn't do inferential statistic without providing the status of the data we have. We need to describe our data, and then after, based on the description we see, we do like an inference, we do like a cross-checking, cross-tabulation to see the relationship among that status for us to be able to take an inference based on that data we have. We need to know the status, and then after we look at the inferential statistics where we have testable proportion. For example, we can say that on the context of inferential statistics, I can assume that there is no relationship between employment level and the gender, for example, in Rwanda. This is the case scenario. Those scenarios that I'm interested to see if it is true or not, it's what we call testable proportion, or in statistical concept is what we call null hypothesis. Those existing scenarios that I'm interested to see if it is true or not. And during that time, in way that I can search, the way that I can confirm if it is true or not, I do research. I collect information from the feed, and then I do description. I describe what happened. I describe like providing a general overview of the information through descriptive statistics. And then after, I come up to the inferential statistics where we have the models to assess the relationship, but where I'm interested to what extent maybe, for example, gender influence employment level. And then after, I do an inference based on the finding, which means we do descriptive statistics, which link us on inferential statistics to take decision. We didn't take decision on the stage of descriptive statistics, but we can take the decision on inferential statistics. I don't know if you understand where that concept, because it's essential for next slide. Yeah, thank you. We can proceed. You can ask a question. Okay.
Uh, for me, I have question. I didn't understand where the meaning of hypothesis testing.
Meaning of hypothesis testing. Okay, it's good. Another question, hypothesis testing. Okay. Who has already knows about hypothesis testing so that they can help me? I want to know if there is anyone who knows that kind of things. He can share, or she or he can share to us. Okay. Yeah. Floor is yours.
Okay, thank you. Uh, my name is Zamaza Prince, and to explain this what hypothesis, allow me to use like an example. So suppose that uh, I come and I tell you that um, in University of Rwanda there are 30,000 students, and I have just I told you that, but I show you no proof. Then uh, that is like an hypothesis, because as you have said, it is like a research or a claim that must be tested. So to understand this, as I tell you that in University of Rwanda there are 30,000 students, then you have to you will have to go and make your own research to see whether I have told you the truth, or whether I told you the truth about the student in that university, or whether I was lying. So that is what we call an hypothesis. Like it's a research or a claim that that must be tested to see whether it is true or not. Thanks.
Yeah, thank you so much. I think you understand hypothesis testing. If not, I can add on. So simply when we say hypothesis testing, there is a scenario, like there is existing scenario, but we some more people they agree on that scenario, and there is others who didn't agree on that scenario. So this is where we apply hypothesis testing. Either we are tested to see if it is true or not, so that we can take decision. So we will see more about hypothesis testing, where we have seen that in hypothesis testing, we have what we call null hypothesis, alternative hypothesis. So when we say null hypothesis, it's what we call those existing scenario. Anyone who raised their hand, okay, you are welcome. Okay. Those who raise their hand, you are welcome. If not, I can proceed. Yeah, you can say. Zanshi, maybe Zanshi, he raised their hand. So I can proceed. I was saying that those scenarios that can needed to be tested, either to accept or not to accept, it's what we call hypothesis testing. Is where we apply hypothesis testing. So we do have what we call null hypothesis. It's like existing scenario, existing scope of that scenario. If many people, it's like a theory. We know that people maybe comes from uh, evolution. We all believe that God they create something like that. All of us we believe Bible. You see something like that. There is a theory behind. That theory behind it's what we call hypothesis testing. So it will be alternative hypothesis when I'm not a measure of central tendency, measure of variability with descriptive statistics. Of course, we are already covered. Know if there is anyone who has knows their relationship among two key aspects. If there is anyone, you can share to us. The floor is yours. Okay. Oh, I can ask someone. I'm going to apply what we call sample. Okay. I'm going to select someone and they present you. Okay. Have numerical data, how to describe should be different from how to describe categorical data. As I said before, we have seen that for numerical data, we describe it by just look at mean, mode, median, something like that in numerical data. And when it comes to categorical data, we describe it by using like frequency, percentage, even their mode, something like that. So the relationship between descriptive statistic and measure of central tendency and even measure of dispersion is that. So when we try to make a description about numerical data, it's where we need to make measure of center. Anyone who has a question? Okay, we can proceed. And I was talking about the measure of central tendency, or variance, measure how much data varies from the mean, okay, things like that. I will go in deep during the kind of analysis, and even we can see how we can interpret it during the data analysis. For example, I'm not going to go in deep here, but I will make sure that you understand the logic behind during the interpretation of data. When we have mean, when we have range, when we have standard deviation, we will go in deep when we have like real world data. What we do here, it's like an overview just to be aware of statistical term that we are going to use in this journal of data science. Yeah. And I want to talk about the part of visualizing data. So for those who access the Google class, maybe I'm going to show you how we use a Google class because I have seen that many people they realize the issues on about the materials on the Google class. Maybe there are some among of you who didn't familiar with Google class. Maybe let's assume that there are some people who see it at the first time. But I upload the document about visualization. So visualization, it will take a session because when it comes to visualization, you mean it's like a graph. For us to be able to understand the visualization in a good way, each data type has their own chart type. So when you see here, the data visualization, it's a graphical representation of information using chart and graph to make complex data easier to understand and interpret. And common visual tool including pie chart, which shows proportion, and proportion it's like percentage, yeah. And bar chart, which compare categorical variables, and histogram, which display the frequency distribution, especially among numerical variables. It's where we apply histogram, scatter plot, those two types of visuals. Histogram scatter plot, box plot, something line plot, something like that is where we apply on numerical data, which means all data type has their specific graph. And when it comes to categorical variable, it's where we use pie chart, shows their proportion, bar chart, which compare the categories. Maybe we are interested to see the relationship between the two categorical variables, maybe gender and employment level. It's where we use bar chart, and even in scatter plot, it helps us to see the relationship. Okay, we see that scatter plot, which river or shows the relationship between variables. During that time, we see what we call dependent variable and independent variable. We will see what we call dependent variable and independent variable at this stage where we focus on scatter plot and all those kind of chart. It's like going through about the data type that we have. So that's why I was preparing the session about the data visualization instead of combining this concept of data visualization on that course. So it will be easier for us so that we can understand it more deeply. And even I was saying that a visualization is essential because it helps us to identify the pattern, trend, insight quickly, making data more accessible for analysis and decision making across various fields. As I said, we during this data science course, we try to look at the different sectors of research, maybe especially in the business, healthcare, and even any field that you are located. And there is some people who comes from the field of social science. So we do the practice about the social science. When we started to do like a project on the softwares that he used in analysis or even data science, providing a model, I hope you understand those kind of things. So if there is anyone who has a question about the visualization, but here, I didn't go in deep about the visualization. We have the session for data visualization. But anyone who has a question, like a curiosity question, you can ask.
I have a question.
Yeah, you can ask.
What's the difference between proportions and frequency distribution? Thank you.
You say about
The difference between proportions and frequency distributions.
yeah, thank you. The difference is one it's like a percentage, another it's like a frequency, counting the repetition. Yeah, counting numbers, repetition. Frequency distribution, it's a count repetition of numbers. For example, if I'm looking for gender, male, where we do frequency distribution, where I say that among 1,000 participants, 700 are female and 300 are male, for example. It's like a frequency distribution. Those variables are numeric, okay? I presented in terms of numeric, for example. And when it comes to uh, proportion, is where I can say 70% of participants are male or 30% of participants are female. It's like in terms of presenting. One, they count the numbers, and other, they count their percentage. Yeah, they calculate their percentage. But mostly they use proportion instead of counting. I don't know if you understand. But when it comes to context of numerical data, it's somehow different. The histogram distribution, maybe the frequency distribution that we said here. So maybe it's like we don't do a percentage when we plot numerical data. It's just, for example, we have the income category. Maybe we have an income variables within the to see how people are distributed. People are different. People are different from others in the context of earning the same amount or the different amount. Here to present the data which is the numeric, we use histogram, and histogram they show us mostly the mode, people who has, or the people income who earned by many people. It's what we call distribution. But when it comes in terms of concept, maybe for categorical variables, because on categorical variables we have both descriptive, we have both frequency distribution and proportion. The difference is that one is presented in numbers and other is presented in terms of percentage. I don't know if you understand.
Yes, I got it. Thank you.
You understand or no?
Yes, I got it. Thank you.
Thank you. Anyone who has a question? Conclude, but we are not end the session, but I want to say something before we conclude. If I ask someone to summarize what we covered here, are you able to do it or not? Okay, I'm going to apply sample. Okay, I'm going to present someone so that they can present you. Yeah.
I was gonna ask on about the difference between sorry. On measures of tendency,
Yeah.
measures of dispersion.
Measure of
When
dispersion.
do you need to use measures of dispersion, and when do you need to use measures of central tendency?
Okay, thank you. When you deal with describing the data in context, that data are already, if it is numeric, no need to use one of those two kind of categories, or one of those kind of measures, like a measure of central tendency and a measure of variability. All those they used at the same time. I don't know if you understand the concept. Why do we need to? The reason why we say the measure of central tendency, it's like a measure of central tendency in the context of numerical data. They show us the general overview of our numerical variables in general, just in general. When we say mean, it's like in general. But when we look at on a measure of variability, within that variables that we have as the numeric, we need to see their difference. We need to see the variation among the participants. Maybe we need to see like the distance between, or the difference between salaries of employees among the company X. And we need to know average salary of employees in the company X. Or we need to know many employees amount they earn on a company X. Or we need to know employees who earn a good or salaries among the company, something like that. All those examples that I give you, if you get it well, I give you example of mean on average salary of employees. I give you the difference, maybe a difference between employees who earn a lower amount and who earn higher amount, like a different. All those kind of measure of central tendency and measure of variability, they work together to provide a general overview on numerical data. No need to separate it during the interpretation. Yeah. I don't know if you understand.
Yes, I understand. But if it's okay, you can give like an example of real life of standard deviation example.
Thank you. Okay. Yeah. Example on a real world scenario where we can use like standard deviation. Consider the scenario where where your daily community to work over the 5 days. Maybe on Monday it take 20 minutes, on Thursday you take 22 minutes, and on Wednesday maybe you take 35 minutes to work on like daily community work over the 5 days, and maybe on Saturday you take like 19 minutes, and maybe on Friday you take 21 minutes. So when we calculate an average, it might be like around maybe 20. So however, to see, we calculate on average over the week. We have seen that on average over the week, it's like I spend 20 minutes per day. Every day I spend 20 minutes when we calculate the mean. So when it comes to standard deviation, it's like we need to know the difference. The difference meaning, which is like on Thursday. Okay, the difference maybe let's say that we calculate the mean, and we see that on average every day we spend like 20 minutes. So when I'm interested to see the difference from the minute I spend on Wednesday, and even for that 20 I get it on average, it's somehow standard deviation could be. And when we see the standard deviation, when it's small compared to the mean, it means that I spend the minute which is lower 20, for example, all days. On average, I spend minute which is over the 20. And when we see that the standard deviation is large from the mean, it means that I spend almost more than 20 minutes every day. And the standard deviation, in conclusion, it gives us an idea of consistency or an unpredictable minute that I spend during that time. So I don't know if you understand, I think a little bit about that. But later we will see more about that. Yeah. Uh, Before we conclude, maybe I want to show you. Okay, anyone who has a question, you can ask. Okay.
Thank you for a good presentation and the explanation about standard deviation. I wish to hear more about what does it mean if standard deviation is higher, or what does it mean if standard deviation is lower? Thank you.
Okay. Mr. Benoit is going to answer first. Okay.